Welcome to Code Club. Please welcome my panel here to help me look at the new embedding feature in Go, which is really cool. This came out in Go 1.16. Has anybody used this yet? I'm guessing not.
I used it because you were talking about looking at embed for an upcoming Code Club. I added it for my tests in
Great.
one of my packages, just to serve test data using embedding instead of opening a file in my test.
Okay, great. So I thought we might set the scene. If you haven't heard of this and you have no idea what it's about, let's set the scene by starting with the problem. It's pretty common to want to get some data from some other file into your Go program, isn't it? There's all sorts of reasons for doing this. You could have data in a file, you could have images, other static assets, things like this. One thing that I thought of was, Dave is working on a Fortune program, so print. If you had a text file full of quotes, which I have, I'm sure most of you have. Everybody's got a quotes file, haven't they? And you could imagine a little Go program which just reads that file and spits out a random quote from the quotes. I have some here, and that's fine, except we can certainly open a file in a Go program and read it, can't we? We know how to do that. One problem with that is that then you need to deploy the file as well as your compiled binary, isn't it? It's really nice. One of the great things about Go is building a single binary file that you can just ship to the machine where it's going to run. It's very annoying to then have to, provide a whole folder tree and set of files along with it. And of course you could tar them up and so forth, but it's annoying to have to do that. So what would be really great is if you could make that file part of the binary somehow, isn't it? I mean, people do this, and we could imagine ways to do that, couldn't we? There are some libraries to do this kind of thing. But what we would like is, if I have quotes.txt, let's say, I'd like it to just turn up in a variable in my program called quotes, a string variable perhaps. Anybody like to speculate on ways that we could do that if you didn't have the embed library, for example? We're engineers, we can solve this problem, can't we? What could you do?
Other than the most obvious, which is just to, like in the case of a formatted string, is to just add the formatted string into a variable manually.
Yep, I like obvious. that probably is the best solution, isn't it? And sometimes the file is really massive, and it sort of obscures all your code by having that giant string in the middle of it. Or maybe there's just lots and lots of them and it's tedious.
I had to do something like this recently, which was for various reasons. We were embedding large JSON structures in our Go code.
Right.
And when you open that in Golang, for example, the IDE, it took Golang a long time because it was trying to both grok the JSON and the Go code.
Right.
So it really slowed down the development cycle.
Yeah, that's not great. And we could also do something like code generation, couldn't we? I mean, we could just use something like a makefile to just cat quotes.txt. You could have sort of the start of your Go program, main header.go quotes.txt and then main footer.go. Just cat those all together and you get some cromulent program that you can then build. That's all right, not great. Go has its own code generation machinery, which you probably don't know about because you haven't had to use it, which is great, so be thankful for that. It's not much fun to have to generate code. But we can use a special magic comment, a compiler pragma, go generate, and then literally any command. And if you run go generate on the command line, it will just find those embedded comments and run the command, which could be a make command, or a Unix pipeline, or even run a Go program. So I was doing this the other day just for fun, just to see how painful it is. You have some Go program which you run, which contains an embedded command to run another Go program, and that Go program, what does it do? Of course, it generates a Go program. So perhaps we use a template, and interpolate some data into our program. This is how Go test works, by the way. I found this out the other day. It's quite interesting. If you look into the testing library, which I recommend, you'll find there's a bit where there's a massive template as a raw string in the program, which is like test so-and-so, and it just generates that, and it sort of scaffolds each of those functions to build some binary with your test code. And it's okay. Also not great, very complicated to do that. And of course you have to write the generator program. What we'd really like is just something to say, look, I have the file, I have quotes.txt, just give me that as a variable, right? That would be ideal. So we have that. So there's this new library called embed, which will do exactly that. And I've put 3 challenges together for us as a group. Let's see if we can do these. So using embedding, can we do the fortune program? Randomly selected quote. Could we serve an image file from an HTTP server? Again, from just one binary. And could we, if we had lots of images, could we choose one at random and serve it? But again, we don't want any folder structure. We don't want to be opening any files. We just want all of this as static data in our program. So should we have a go? I think we can do this, can't we? Let's go into quote. Let's do a main.go. There's a snippet for this. Okay, who'd like to start us off? Suppose let's assume that we have the quotes variable, and we just want to print something random from it, and then we'll figure out how to embed that. So suppose we had, var quotes is a string.
I mean, we're going to want to split it into the individual quotes, and probably on a new line, right?
Yeah, in fact, they're separated by a blank line. So if we split on double new line, that's probably enough, isn't it? So what does string split return? It returns a slice of string and error. Maybe not. I need a go.mod here, don't I? Let me create one. Okay. Import strings. Returns a slice of string. Great. Okay, so let's make that quotes, and let's just make this like quote data, something like that. Seem reasonable? Okay, we've got quotes. Can we get a random one from this slice?
Yeah, we're gonna essentially seed a random generator based on the size of the length of the quotes, right?
Yeah, so we need to seed our random generator just to make sure we don't get the same sequence of random numbers every time. See Code Club's +im for more about that. So we've initialized that, so we have quotes, and we can say quotes what? We can use the rand library here, can't we? How about rand int_n?
And then, yeah, len quotes, right?
Len quotes. Yeah, this is sort of an idiom, isn't it? It's like, give me a random element of this slice. So first of all, find the length of the slice, compute a random number between 0 and not including that, and then use that as the slice index to get quotes. It looks a bit, too many brackets, but it's all right, isn't it? We recognize this. And we can probably just print that. So, great. So the question is now, how do we embed that stuff, so we need the magic comment. So this is go : embed, and then some file, quotes.txt. So one interesting thing about these magic comments, which are instructions to the compiler, is that they never have a space after the comment marker. It's always / go something, go generate, go embed, whatever. And that's helpful, isn't it? Because it means when we write comments, if we always put a space after the slashes, here comes the embedding, we can never accidentally write a compiler pragma that way, can we? I mean, this may be unlikely that we would, but I just feel a little bit uneasy about, like, hey, if you accidentally write something in your comment, it could completely change the way the compiler works. That's not so great. I don't love magic comments. I don't think anyone does, do they? But we are where we are. So now we have another one. Go embed. So let's see if this works. Okay, so it recognized the go embed, all right, but it says you need to import the embed library to sort of enable that. So we can do that, no problem. And I guess it just disappeared again. So because go imports will helpfully remove any library that you don't use. But we don't actually use the name embed, in code. We don't say embed.something. So what can we do? It's really a side effect import, isn't it?
Like underscore package?
Yeah, we can just alias it to the blank identifier, underscore, and similar to if you import a database driver, where you're importing it purely for the side effect and you won't be using that library's names. You can do this. That was previously the only legit reason for doing an import alias that I know of. Now there's another one. But in general, we don't want to alias things that we import, do we? If they have the wrong package name, then we should just fix the package name. Because otherwise, people reading the code will have no idea what library you're referring to. I've seen people alias standard library packages to different things, and that's a complete no-no, because people will just be like, what's that library? I've never heard of it. There are some annoying things like if a package has the same name as a standard library package. For example, GoKit has an HTTP package. So that's going to conflict with the standard library one. So you sort of feel like that's a mistake by GoKit, isn't it? You probably shouldn't name your packages the same as standard library. That's a rant for another day. So we've successfully imported embed, so this should work now. Great. Yeah, let's try a couple more. Yeah, this is looking good. I have a lot of quotes here. So it's like, what, several thousand. So that could keep us happy for a while. Does that solve your Fortune project, Dave? Expect it does.
Indeed it does. In fact, the embedding stuff is exactly what I need for the next week.
Great. That's always nice when the timing works out like that, isn't it? So, okay. Challenge 1 completed, I think, isn't it? Should we have a question or two about this?
One thing I just completely neglected to understand about embedding when I was reading about it was that that the data gets embedded into the binary.
Yeah.
It's in the word, but I completely missed that it wasn't just a nice way to read a file.
Yeah, absolutely. No, that's a very good point, because we should do a go build, shouldn't we? And let's look at what we got. So we got a 2.1 meg binary. So that there's 116k of quotes included in there. And if I just delete the text file, then it should still work. Yep. So yeah, that binary actually has all of that data in it. And presumably the compiler just does something like equals big raw string from the file, isn't it? I mean, we could so trivially write that as a preprocessor, if you like. but we don't need to. So this is fine. So it's like complaining about no matching files. Yeah, indeed. So a couple of questions here is like, this go embed comment, it comes right before the definite. How does it know where to embed it? You know, the answer is you need to mention some variable immediately after this comment. So I think if we should we try putting a blank line or something, and I'll just put something in that file to make it compile. Yes, it is there. So let's try it. Yep, that's working. So let's say something else, you know, bogus. Right. So you can see what it's doing, can't you? It's saying, oh, there's a go embed directive. Okay, I'm going to look for some variable immediately after that. Not an int, ideally. Doesn't make much sense to put that data into an int, does it? So string is all right. What other types of things could there be? Well, one thing is a slice of byte, because that file could be binary, couldn't it? So the next challenge is to serve an image via HTTP, because we're the cool gang, so we can probably do that, can't we? Let's try. So I have an image here, which I prepared earlier. And can we write, first of all, can we write a little HTTP server? I think we can. You help me out here. What should we do? Let's serve some HTTP first, and then we'll figure out what to serve.
Create a listener.
Yeah, something from the HTTP library, perhaps.
Yeah. HTTP.list-and-serve.
Yeah. Sounds reasonable. This is the default server, which we wouldn't normally use because it doesn't have timeouts and things, but that's okay. This is just for play, isn't it? So let's say port 999 and nil, because we're not passing it a server, or we're not passing it a handler. We're just using all the defaults. So let's see if we can run this. No, wrong one. Okay. That's probably, whoops.
Now you need to accept a new connection.
Yeah, let's run that in the background and just see if we can curl it.
No, because it's not accepting connection yet. Oh.
Yeah, it is. It's giving me 404, which makes sense because there's no handler at all for any route that we could imagine. So we get 404 by default. Okay. Let's write some handler then. So we can call handle func. Give it some pattern to match, so just slash is fine, isn't it? Any requests to the server are just going to receive the image. There's only one thing we do, and it takes a handler, so I've got a snippet for that, mainly because I can never remember it. So now I don't have to. This is great. So an empty handler is perfectly fine, so this should just respond 200 and nothing, doesn't it? Yeah, I'd see a complaint if there's a problem, and there isn't, so that's great. So let's just, say hello. We can fprintln to the response writer. Hello, Code Club. Actually we have a browser.
Because you run -I, it's not going to show the body.
Yeah, we have a browser in fact in VS Code, so we can use that. Yeah, that works. Hello, Code Club. Okay. What can we do then? We'd like to display this rocket image, wouldn't we?
Yeah, just need to write the image in the handler instead of Code Club.
Yeah, but we need to get it first, don't we?
Yeah, now it's the embed part.
So we'll do go embed rocket.ping, let's say. Now we need some variable, don't we?
Yeah.
What would make sense here?
Maybe image.image.
Well, what we have is a ping image, in fact. We could use image/ping to decode it into an image.image, but we don't really need to because we can serve a ping image directly, can't we, if we set the right content type?
Right. So just read as binary.
Yeah, I think a slice of byte would make sense here, wouldn't it?
Mm-hmm. Yeah.
Let's try that.
And don't you have to? I mean, there's a limited number of types you can use for embedding, right?
Yeah, I think it's exactly 3. So we're on our second now. So it'll be exciting to find out what the third one is. But yeah, so in theory, if this has worked, we should have the ping data in that slice of byte. So John, perhaps you can help me here. What should we do if we want to serve that? We have that slice of byte, and we essentially just want to send it straight back to the browser, don't we? What can we do here?
Can we simply use IO-Writer to write it to the response writer?
Yeah, sounds right. So we should send a content type, shouldn't we? To say, hey, here comes a ping. You know, not just arbitrary binary data. So that is we can use header set. I think header set. Yeah, that takes the header. So content type. Image/ping. Sounds right, doesn't it? Then what? Okay, content type established. Here comes the data. How can we send it?
Can we use io.Util to just copy it to the response writer?
Yeah, io.Copy, in fact, is probably what we want here, isn't it?
Right.
If you have a reader, if you like, and well, we don't have a reader, do we? io.Copy would be ideal if we had a reader and we wanted to send its contents to a writer. Instead, actually, we can just use the write method, can't we? We normally don't call write very much because it's byte oriented, and we usually have a string or something like that, or some other thing which is inconvenient. But this is great, so we can just write contents of image. Okay, fine. Don't need to close anything because we didn't open anything, which is nice. There's no danger of leaking file resources or anything, so that looks all right, doesn't it? Let's try this now. Did I kill the old one yet? No. Oops. I didn't import embed. How about now? Yep. Hey, not bad. So that's pretty cool, isn't it? It's not the worst Go program you've ever seen.
What happens if you were to set the string or the type of image to string? I have a presumption as to what will happen.
I guess, well, yeah, my guess would be we get all of the same bytes, but they're in a string now, so, you know, they would normally be treated as Unicode code points.
You can't write a string also, so
Well,
you
cast it.
Yeah,
Yeah.
we could just
Yeah.
fprint. We could fprint ln again, couldn't we? Print that, and let's So yep, that's fine. So, but it's just a useless use of string, really, isn't it? Because what we have is slice of byte, and it can stay as bytes. No,
it doesn't need to be passed back and forth implicitly.
Yeah, the only reason to ever have a string about something is if you want to treat it as a sequence of characters, which it absolutely is not. I mean, clearly this works, but we don't need to use any sort of string methods on it or anything like that. So slice of byte is appropriate, and that probably covers most of the main use cases, doesn't it? You know, it's either text data, in which case string is fine, or slice of byte for literally everything else. And the third challenge is it's the same, but this time we're going to have multiple images, and we want to pick one at random and serve it. So I have some which I've prepared earlier, not me. These are Creative Commons images. And except this one, how did that get in there? That's a mistake. That just seems to be advertising material for my new For the Love of Go video course. I understand that's available, but you know, we don't need to see that here, do we? It's just shameless commercialism. Very wrong. All right, let's try then. Let's do our main.go. Shall we start by copying and pasting what we already had? Copy and paste School of Programming. Package main. Okay. Now, what we want to embed is we could individually embed each of these files by name, of course, but that would be irritating. And we would like to be able to just drop more images in there and rebuild the program without having to change the code. So we would like to do something like embed image star. This works, I hope. What do we get though if you embed that? What kind of variable would be appropriate? Well, you could imagine a few different possibilities, couldn't you? Like string and slice of byte don't really make sense. Slice of?
Like a map where the file name is the key and the slice of bytes is the data.
That would actually be that would be pretty convenient. What we can actually use is there's a new type called embed.FS for file system. So now we don't need the blank identifier alias because we are actually referencing package embed. That's good. So what is an embed.FS? Well, it's an fs.FS. I realise that's not a super helpful answer, but it's the right one. fs.FS is an interface which sort of abstracts file systems in general. Like, you know, if you think about something, you know, a tree of files on disk, what you basically have is sort of a tree structure of folders that can contain folders plus files, isn't it? And that could be as big as you like. And you'd like to do things like tell me all of the entries in a particular folder, you know, open one of those things. Could well be a file, but it doesn't have to be, does it? This abstraction just sort of applies to any kind of tree structured data, as Dave said, where you have a sort of a tree of strings mapping to some resources. This is quite general, and there are several places in the Go standard library where things like this existed, but they were all sort of slightly different and incompatible. And when they were working on the proposal for how embed would work, they said, you know, it would totally make sense if we just have one file system abstraction for everything, and then embed can just use that, and we'll retrofit it to all of the other things. So, you know, now if you want to open, you know, a tree of files on disk, you can do that. If you want to make a memory-based file system for testing, you know, now it's pretty trivial to do that because you just have to implement fs.FS and that's a very small interface. And we would like to, let me just see if I can show this. io.FS, yeah, here it is. It's the method set open. So that's nice, isn't it? We like small interfaces which are easy to implement. And it takes some name, and what it returns to you is an fs.file. This is another new type, and error, of course. So embed.FS is an implementation of this. So when you embed stuff, like the image directory, what you'll get is this fs object, which you can call open on. So we will, among other things. So
did I filter the extension like .png or no? In the Go embed, like in img / star, could I add a .png line 9?
line 9, yes.
Could I filter like .png?
Yeah, absolutely. We don't need to in this case, but and we can see, like, if there were no files matching that glob, then we would get a compile error, which is helpful. But yeah, so we don't need it as such. And so, okay, so we have, let's call this images. That's reasonable, isn't it? So we're going to do something random. So let's seed our random generator. Okay. What else do we need to do? Any suggestions?
Get the number of files available.
Well, we would like to, what would we like to have here? We would like to have a slice of, slice is a byte, wouldn't we? Or, no, that's not quite right, because we would like to have a slice of files, I think, isn't it? Or a slice of a slice of file names would make sense. Because what we're going to do is we're going to open them. We know we have the method set open on images, so we can call images.open some file name, you know.
Wouldn't we want to just choose a random one to open first? So wouldn't we do like the reader on the images?
Yeah, this sounds good, doesn't it? So we want the list of images that there are. We want their names. We want to choose one of those names at random, and then we can open that one. We could, of course, open them all, you know, and read them all, and then just use one of them at random, but that would be a bit wasteful. So let's, yeah, you said read dir. So this is not part of the fs.FS interface. This is an embed.FS method. So it just has internal files, but it also has a read dir method. What does that take? Some path to read, which image would make sense, wouldn't it? So this file system object is rooted at the same place we started here. So, you know, img is a subfolder of this folder, so we start here, and then the first, effectively our fs.FS object will have one entry, which is img, isn't it? And then inside that we'll have some entries. This returns a slice of something. What? A slice of fs.DirEntries. Okay, what are those? We'll find out. Let's just call them entries.
John, one question. The image is not already a slice of files?
Images is an embed.FS. That's what it is.
Yeah, but we have inside of the structure, we have a slice of files.
Yes, but we can't access them. These are private.
Oh, okay. I didn't see. So
Yeah, the only way we can get to those is to say, please open the name. Please open this named file that I'm going to tell you. Music.ping, let's say. How do we know those names? The answer is we call readdir, and we get this thing called an fs.DirEntry, and we can do something with that. Is one thing we can do is we can pick a random one, isn't it? So that would be in the handler. So we know how to pick a random element from a slice, don't we? That would be, any suggestions?
we can use the same method, the length, hinging of the length.
Yeah, rand_int_n.
Yep.
Len entries. Yeah. That's fine. I was chuckling earlier on today at someone tweeting that, you know, like, I can't believe Golang is so dumb, you know, there isn't even anything in the standard library to like pop the last element off a slice. And I was just thinking, well, maybe Go is aimed at people who could write that method. You know, it's like, sounds a bit elitist, but I think, like, you know, it's amazing how far you can get in software engineering by just calling standard library functions, isn't it? Or third-party libraries. You know, in a sense, you can sort of write entire non-trivial applications without really writing any code yourself at all, is it? Just gluing together things that already exist. And that's okay. It's highly productive if you, but it's helpful to know how to write code, because sooner or later you'll have to. And here's an example. So we don't have a sort of entries.rand element, but
Yeah.
we can write it.
Let's abstract things that's really complicated, like mutex and memory synchronization.
Yeah, exactly.
Like,
Yeah, I don't mind writing random element. I don't want to have to write listen and serve, for example. So it's nice that that's there. Okay, what's next? So we've picked a random element. What should we do with it?
You should assign it to a variable, right?
Yeah.
Yeah, so let's say that's image path. Okay, so that's an fs.DirEntry. What can we do with it? Let's find out. We can call info to go to file info. Probably not that interesting. We can find out, is it a directory? And we can get its name. And that's probably what we want, isn't it? That's what we're going to use to open the file. So it's a bit weird, isn't it? Because we've said we wouldn't be opening any files, but we are, just not from disk, from this static embed.FS entity that exists in our program. So, okay, we've got the name. We want to call open images.open. So that's the one and only method that an fs.FS has, is you can call open on it. You might say, well, that doesn't sound that useful. You know, it's so limited. But that's sort of the Go way, isn't it? Rather than provide some massive interface that includes everything you could ever want to do with a file system, just make a super basic one that's like MVP, and then you can always compose more interfaces on top of that. You could imagine an fs.readDirEFS, couldn't you? Or, you know, even file systems which have the ability to write to files. We can't do that with an fs.FS. It's only for reading stuff. Luckily, that's mostly what we need to do, so that's okay. Fine. So what does open return? It returns an fs.file. Okay. What is that? We'll find out. I'm sure that can error. Yes, it can error. So we better check that. We are an HTTP handler, so we can do error what? It's hard to imagine what this would be, given that it's the file system itself which told us what entries there are, and we just said, okay, open that one. But, you know, we spend a lot of time handling 6 impossible errors before breakfast in Go programming, don't we? We just think, you know, even if I believe it's impossible that this could ever occur, all that really means is I can't imagine a circumstance where it could error. But my imagination is finite, you know. So quite often situations happen where I couldn't have imagined that it would happen. So we'll definitely error in that case. To W, and we can say no soup for you, no images for you. Seems like an internal server error, doesn't it? Insufficient storage. Never seen that one. it's there. Okay. That's not bad, isn't it? What else do we need?
This might be a good place for the io.Copy, right? The file is it fulfill IO reader? Or...
Yeah, absolutely. In fact, because we've just opened a leakable resource and we've established that we definitely have it, we should defer closing it. So let's do that. And so now we have that reader, an fs.file is just like an os.file, except it's an abstraction. So, yep, so content type is still correct, isn't it? And we just want to io.Copy. And of course, this is backwards. So you're saying copy to W the contents of F. This is guaranteed to confuse you for the rest of your life now.
Yeah, it confused me even every time I had to use.
Yeah, what you do is you just remember it's the opposite way around to the first thing you think of. And then once you've internalized that, you think of it the right way around first, and then you say, no, it's the opposite of what I think of first. And so you end up with it being wrong. It's a little bit like steering a canal boat, where I tried to apply the same logic and crashed into the bank. Sorry, Steve.
Good tip, thanks.
So yeah, this is fine. So we've opened it, we've set the header, we've copied it to the writer. So we should be able to do something, shouldn't we? It's exited.
The old one's still running.
Oh, is it? Yeah. Yeah. Let's kill that one. Okay, yeah, I should have received the error from listen and serve and log fatal bit, shouldn't I?
That's my fault because this piece of code I didn't set it.
Okay, it's running. So, do we have something? No, that's disappointing, isn't it? But let's see if we can figure out what's wrong. Should we just log that we got the request at all? And let's see if we see it. No, we don't see it. That's a bit puzzling. Let me just close this and try curl. Yes, it's okay. Yes, we got a ping. Turn off headers. Something there, isn't it? So it's not so easy to read as raw bytes. Lolcat host 9999. Nothing.
There's something
Looks
wrong
like
with
it's
the,
written
with
as
the content
live.
type or the way that the data is being copied.
Well, there's data here, isn't there? Lots
Yeah,
of
but
data.
I mean, like, does the browser not know how to interpolate the data?
Looks like it's passing a slice.
Oh, it totally is.
Where
Right, content type. Here we are.
there's an awful lot of data here, so I think the server is working fine, but the browser is just not showing it correctly.
You see, it's passing a slice. Shouldn't be a slice.
That's not Go output, that's curl's output. So
Oh, right.
Let's just check if, yeah, this is the base name of the entry. So actually it needs to be preceded by img, doesn't it? So it's interesting that we didn't get an error, I don't think. So we said something, but I'm not sure what.
This is the virtual path, no?
Yeah, that's right.
So if you do the curl again with a dash V, you'll see all the headers, and if you do a dash small o dev null, you won't see all the output, and we can see if we're receiving the right content type in the browser, or in the terminal at least, or whether the data is not valid as it comes through. And the other thing, we can just type the output itself with file and check the SHA-256 to see if the raw data is correct. It's just a representation of the prompt.
Yeah, okay, let's see if we need to do that. So let's just log what we've computed the image path is going to be and see if that even vaguely makes sense. Let's try. Nope. That didn't get very far, did it?
The old one's still running?
Oh yes, quite probably, yeah. Funny that I still didn't see an error from listen and serve, but there you go.
Yeah.
So now it's running. Okay, I'm going to try the simple browser again. Not totally convinced that this actually works. Nothing recorded on standard out, so that's a little concerning. Let's try curl again. Let's just try I. Yep, we're getting it.
Shouldn't we pass the... Oh, you're
We're
already
not.
setting the handle function.
Yeah, we're not seeing any output though, are we?
You have to put a slash after your file path, image slash name.
Very likely, but I want to see it printing it out wrong, if you know what I mean.
Yeah,
It's
I've
not-
had this problem before. Do you do log instead, or?
John, run a PS and grab by go build. See if you have a bunch of main running. I have this problem.
We'll do. I don't think I have anything listening on 999 now. No, I don't. So that's all right. So that tells us we haven't got any squatters on that port. That's all right. So let's run. Oh wait, I think I'm in the wrong directory. This just underlines my point. That deliberate mistake that I just made was designed to, you know, create this teachable moment. Like, it's really important to pay attention to exactly what's on the screen, isn't it? You can stare at this for ages and just go, why is it not doing anything? And the answer is, well, I'm running some completely different program. So thanks for playing along with me while I did that. So now let's try running this program. Because this bears no relation to what we were just doing. So fine.
The fact that it never printed the URL.
Yeah, that was worrying me. And this just proves my well-known mantra that, you know, if you don't understand what's going on, just keep adding print statements until you do. Because something's going on. Okay, we've got a panic. That's good. So here's the URL. It's interesting to see that's what the VS Code simple browser does. We computed image no slash rocket.png, so that's absolutely right. We need a slash there.
Oh, I think you should remove it now, because we just added in the troubleshooting, and I don't think we need to concatenate this EMG, because it's a virtual path that's given for you from the handler, not from the handler for the FS.
We'll find out, won't we? So where's the panic being thrown? It's here. Really? Oh, then I guess f is null, or nil rather, which would make sense because that image doesn't exist. So why are we not getting an error though? That's slightly weird, isn't it? Oh, we didn't return. That's probably what it is. Okay, let's try that. Live coding without a net, people. We're through the looking glass. Okay, let's try. Great. Okay, so we see the error. So that image doesn't exist. So let's just check if we don't need to prepend anything at all. Maybe we don't. Still no soup. So I think it is prepend image slash, which makes sense, doesn't it? Because we're saying the root of this fs is the current directory, the one that contains img. Then you've got a subdirectory, img, and you've got some more files within that. So when I said readdir, I said readdir img, not readdir dot. If I'd done that, I would have got just img, wouldn't I? And let's just satisfy ourselves about that. No. Slightly unexpected.
Yeah, that's my point. If you are embedding, it shouldn't have, maybe it's embedded with the same structure. Yeah.
Yeah, we'd like to print that as a string, wouldn't we? Yeah, not that helpful. Let's ignore that. And let's say, okay, so we want to prepend img slash. We should get something. No. Oh, img, yeah, right, because I didn't, because I changed this to dot. So, but that proves the point, doesn't it? That what you get if you read dir dot is you get img, and if you read dir img, you get all of these files, hopefully. Hey, we've got something. Let's try again. Yep. Ah, that advertising again. That's awful, isn't it? Just completely ruins the whole non-commercial nature of this. I don't know who put that in, but I'm going to be having a word with my interns about that. Yep, that looks pretty good. So happy with that. Okay, we kind of did it, didn't we? We did the challenge. So questions about this? Because we have a little time in hand. Everyone's on their game today because I thought this was going to take us longer. Well done, panel.
Yeah, I mean, I think the format of saying what you want to pull in, so for the file system, or the embed.FS, is a little bit. I wouldn't have expected that, right? I think I would have expected just to say, hey, I want to embed img, and that everything inside of img would be at the root of the file system.
Yeah.
Rather than what occurred, and it's fine that it works that way, right? Now I know, and now I'm sure I'll have to look it up and get it wrong a few times. But
yeah, I agree. I think that would be slightly more intuitive. In that you sort of say, or you could imagine that it's like, I want to, having read this directory, clearly I'm interested in opening files from that directory. So instead of a slice of dir entries or something, I might have got some, another FS. You could imagine like an open dir method, couldn't you? That like, okay, I'm only interested in img. So just open that, and then all of my files will just be entries in the root, as you said, Thom. So sadly, that's not the way it works, but you could imagine this is a much more complicated tree, couldn't you? So if in doubt, just keep printing until you work out what's there.
I can see the FS module being used for things that aren't really file systems at all. And in that case, saying, give me a list of all the, let's say, you wanted to extract a list of stuff from Amazon. So you go, give me a list of all the S3 buckets.
Yeah.
You're going to have to iterate through that anyway. So I could understand why this might be a little more restrictive in its API compared to a normal file system, but that potentially makes it a lot more useful.
Yeah, that's right. And anything, an fs.FS can represent any kind of file system, including networked file systems and things. But as you say, basically any tree structure data, it's a bit like Plan 9, isn't it, where everything is a file in a tree. You could imagine that this leads to horrendous performance, a bit like ORMs, where, like, you just do some innocent-looking file system open thing, and actually it's ends up talking to servers halfway around the world or something. But that's okay. I mean, it's, abstractions are useful as long as we know that's what they are. And I think it's nice that it's so easy to implement fs.FS. That makes it more likely for it to be implemented, doesn't it? If you've ever tried to test stuff that uses the file system, like, imagine writing a backup tool or something. It has to basically recurse through a huge tree of files using filepath.Walk or something like that. So to test that, you don't want to do a lot of slow and tedious disk operations. You'd like to have a memory-based file system, and there is a well-known sort of de facto standard library package for that, afro. So there's an afro.FS, I think. And that is an interface, but it has something like 10 or 15 methods. Everything you could ever want. Open, read, write, delete, read, dir. I can't think of any more, but there are. So it's a real pain to implement that yourself if you had to, because you can use afro. But the point is, now you don't need to, because if your code deals with file systems, you should definitely refactor it to tackle that data as an fs.FS. And that being so, it's very easy to implement a fake one for tests, isn't it? Or a dummy one, let's say. So that's quite nice, and we might have a go at that in a future code club, is implementing something as an FS, just for fun. You could imagine maybe processes or something, couldn't you? The tree structure of your processes would just be sort of parent and child processes. That might be kind of nice. So fine. Well, I think we're done. So, any further comments about embedding or questions? One thing that occurred to me is that whenever cool new stuff like this comes into Go, which it does about every major release, the question is, when can I use this? I always want to use it straight away. But the problem with that is, this is Go 1.16, which I have. But if someone was to try and build this program on Go 1.15, it just won't build. There's no such library as embed. It just doesn't work. So you might just say, well, just upgrade already. What do you not read the news or something? 1.16 has been out for a while. But there was a Twitter discussion about this recently with one or two people with quite sensible opinions, which is a subset of Twitter, as you know. But the point was made that not everybody can upgrade instantly. In a corporate environment, probably has to go through some sort of lengthy approvals process, which, while pointless and useless, is nonetheless time-consuming. How long could that take? We can speculate, can't we, those of us who worked in big companies, or still do. If you said to your manager, hey, there's this software that was released literally yesterday, and it's on the front page of Hacker News now, can I start doing production builds with that and deploying them? Probably not.
Yeah. I mean, it would all be about, am I sharing this package with somebody else for them to utilize? Or am I using it only using it and building a binary myself? Embedding seems to be one of those that's like possibly less volatile, because you're likely going to use it for your own builds.
Yeah.
Not for somebody else's.
Yeah, I mean, there are definitely new things that come into Go that don't break backward compatibility in any way, which they never do, and that's great. They're always adding to what's already there. So, code that you write now will still run in 10 years' time. Code written in 2010 still compiles and builds perfectly. But if you use the thing that doesn't exist in previous versions, then people can't use that. And the question is then, what could you do? Well, one thing you could do is you could say, you could guard this file with a build tag like plus build Go 1.16, whatever, which if you don't have Go 116 or better, we'll just ignore it, you know, like any build tag. It will just make it invisible to the Go tools. Your program won't work, so if whatever it is you're doing, you'd need to provide some alternate way of doing that, wouldn't you? Like code generation or something like that, which sounds awful, you know. I really don't want to be doing that kind of thing. Like, build tags are bad enough as it is. I don't want to add more complication to it. It's essentially a meta program, isn't it? You know, all of your build tags add up to a meta program about what gets compiled, and it's really hard to read and reason about that program. So we're going to keep it pretty simple. So I think, you know, there are things where, like, you know, OS distributions distribute some ridiculously old version of Go. Like, you know, Debian-like systems are notorious for this, aren't they? Like, I don't know what Go version is currently shipping in Debian, but it's not 116. I'd be prepared to bet on that. More like 110 or something. So that's, you know, I think you have to draw the line somewhere, don't you? You can't say, you know, I'm writing a program and I need to make sure it works on every Go version, even back to, you know, Debian times. I just don't think that's practical. I don't think anybody would, even if we said that they should.
And even if, as long as someone's not using modules, so using Go 111, wouldn't your Go mod, like having the required, like 1.16 required in your Go mod gate, whether or not somebody could, you know, compile the package even?
Yeah, that's right. And yeah, I mean, I definitely, I mean, there's no need now to take any special action to make your code build for people who have a pre-modules version of Go. That's been out since at least 14, hasn't it? So that's 2 major versions ago. So I think that's kind of a reasonable compromise, isn't it? Is if you say any code that I release publicly should build on the current Go, the major version before, and the major version before that would be ideal. Because it's 6 monthly, isn't it? There's 2 releases a year. So you're saying, you know, you have a year for your unnecessarily slow corporate upgrade approval process. And beyond that, I think you need to fix the process. You know, I'm willing to wait a year to start using the sexy new stuff like embed, but not much longer. And that's sort of, you know, I think if you're writing your program now, you know, if you think of it in terms of, will I be breaking this library for all my many users? Well, if you're writing a new library today, you don't have any users, so you don't need to worry about breaking anyone's code. You can just use embed, and you can just say, you need Go 116 to use this library. Like, if you don't have it, if you have a perfectly good excuse for not having it, that's fine. I just can't help you. However, if you already had some well-established library, and you're saying, hey folks, I'm switching to using embed now. That's it. I've thrown the switch. You know, everybody needs to suddenly scramble to get to 116 to continue using it, and you can do a v2, of course, so that people have to opt in to upgrade. That would make sense. It's a breaking change, isn't it? So I think that sounds like a reasonable compromise, doesn't it? As if you're doing new stuff today, greenfield deployment, new library, you can use current Go features. But if you're thinking about upgrading your existing library to take advantage of them, you should either wait 2 major versions or do the new thing but guard it with a build tag or use Go mod or something and provide some fallback method for people. That's sort of reasonable, isn't it? It's never really been an issue for me because I don't write a lot of code that has users. You know, it's mostly me or clients or whatever. But I always encourage everybody to code as though you're writing a library which is going to have 1 million users and be in production at scale for 10 years in, let's say, health critical applications. With that mindset, you really sort of think differently about your program, don't you? especially because I don't want to get sued by the grieving relatives of my victims. You know, that's the last kind of situation I want to be in. So I think that's a nice way to play it. So go forth and use embed to do cool stuff. This eliminates a whole bunch of use cases for code generation, which is marvelous, isn't it? The less code we have to generate, the better. And we don't need, hopefully you don't need so many make files. I love make, but I don't want to have to use it with Go programs unless I really, really have to, because Go already provides, you know, a one-shot go get, download, compile, and install. The minute you add an extra step to that, like make, you just break that whole chain, which is a shame. So go forth and use embed and play around with it and see what you come up with. And I'll have a look for, you know, see if there are any libraries which are using this already, and maybe put a link in the description. And we might take a look at them in the future Code Club. All right then, thank you very much, panel. It's been great to have you. We've had fun today, haven't we?
Yes.
Wonderful. I'll see you in the next Code Club.
Happy
Bye.
Friday. Thank you.
Thank you.
Thanks, Greg.